Hi. Uh, Infinity. It's quite dramatic. And in this video, I hope to uh, explain that a little more in depth by approaching a proof that the square root of 2 is irrational. Actually, this proof can prove many square roots, cube roots, and so forth are irrational. It is not the even-odd proof that is very commonly used, and I wanted to bring this to people's attention a little more if possible. We're just going to cover square root of 2 in this video, although this technique can be used in many other situations. It's quite versatile. First, and most importantly, is that the square of a fully reduced fraction that has a denominator that is not 1 or 0 can never be a whole number. I need to stress that. This is a really important idea here. Let's look at 3/2 squared. We can see that 3/2 squared is 3/2 times 3/2. That's 9/4 or 2 1/4. So this fraction is fully reduced. The 3 and the 2 have no common factors other than 1. When we square it, we get no new factors. We still have 2's that make the 4 and 3's that make the 9. So this can't be a whole number. And we get 2 1/4. Here's one more example. 7/5 squared. Well, that's 7/5 times 7/5. 49 25ths. Again, by squaring, we get no new factors. We got 7's in the numerator, 5's in the denominator. Nothing can cancel. We cannot get a whole number. And indeed, we get 1 and 24 25ths here. Try other fractions if you need to, but this is a really important idea here. And that is that if you square a fully reduced fraction with a denominator that's not 1 here, and of course not 0, you will never get a whole number. Furthermore, both these examples, these fractions I chose, are very close to square root of 2. Notice that 2 1/4 is just a bit bigger than 2. When we squared 3/2, we got a number just a bit bigger than 2. And when we squared 7/5, we got a number just a little bit smaller than 2. So it's clear that square root of 2 must be between 1 and 2. So square root of 2 can't be a whole number. Okay. The next thing we're going to assume is that square root of 2 is rational, and therefore can be written as a ratio of integers. We can write square root of 2 equals p over q. P over q are going to be positive integers here. We also need to introduce, based on what I was saying before, some important initial conditions for what follows, and that is that q, the denominator, can't be equal to 1. Obviously, we get a whole number, and we know square root of 2 is between 1 and 2. And therefore, p over q is not a whole number. So q can't be 1, p over q can't be a whole number. That's really important. Also, we're going to assume that p over q is fully reduced. We can assume this because, well, if there was a greatest common factor, we could call it g. In the numerator and denominator, here's the two g's, but we could cancel that and just get 1. So we're going to assume we've done that, so p over q can be safely assumed to be, in lowest terms, p and q have no common factors except for the number 1. So we have square root of 2 equals p over q. If we square both sides, we get 2 equals p squared over q squared. Is this last statement possible, actually? I don't think so. Why is this impossible? 2 is a whole number. But we carefully went over the fact that if you take a fully reduced fraction with a denominator that's not 1, and we know that p over q is being assumed to be such a fraction, when we square it, we will not get a whole number. Okay? It's really important to go back over the earlier part of this video if you're confused about that. What that says is 2 cannot equal p squared over q squared. In other words, this is impossible, and 2 is not equal to p squared over q squared. Therefore, our assumption that square root of 2 could equal a fraction that we started with has to be wrong because it led to mathematical nonsense. So, our assumption that square root of 2 could equal a fraction, a ratio of integers, is wrong. Integers without a 1 in the denominator. And therefore, square root of 2 can't be rational, so it must be what? Irrational. And if you like, make a search at Google for the first 10 million digits of square root of 2, and you may find a post by NASA that has their best computer estimate of the first 10 million digits of square root of 2, an astounding number, sometimes called the monster in the unit square. I hope this has been clear, and I hope to do some follow-up videos that take this farther and deeper. Have a great day, and may the math be with us.